Hello, good evening. We are Group 5. This is our second case analysis. Our members consist of Ayson, Eduvane, Martin, Telpo, and Villanueva.
Now for the case facts. There are three key individuals, Jim Wells, Jerry Carstairs, and the management scientist hired by Jerry Carstairs to analyze the proposal and make recommendations using management science techniques, which is us. Now, to quick brief overview of the problem itself and a refresh is the Northern Airplane Company is experiencing a significant issue with high in-process inventory, specifically large sheets of specially processed metal waiting to be formed into wing sections at the presses, then the wing sections waiting for inspection. This is leading to millions of dollars tied up in inventory, and Jim Wells views the inspection station as a bottleneck. Now, the current status quo, to so to speak, is the presses, 10 identical presses used to form wing sections. Sheets arrive randomly at a mean rate of 7 per hour. Time required by a press to form a wing section is exponentially distributed with a mean of 1 hour. Now, within the inspection station itself, wing sections arrive randomly at the same rate as metal sheets arrived at the presses, 7 per hour. Now, one full-time inspector, inspection time is 7.5 minutes per section or 8 wing sections per hour. This inspection rate has resulted in substantial amount of in-process inventory, a large number of wing sheets waiting to complete inspection, so to speak. Now, additional in-process inventory is already found at the group of machines or the presses. Now, the cost of the in-process inventory is estimated to be about $16 per hour per metal sheet at the presses of each wings or each wing section at the inspection station. Now, the proposals made by Jerry Carstairs is the first proposal use slightly less power for the presses, which would increase their average time to form a wing section to 1.2 hours. Now, this would allow the inspector to keep up with their output better. This would reduce the cost for each machine, operating cost plus capital recovery cost from $14 to $13 per hour. Alternatively, increasing maximum power would increase these costs to $15 per hour while decreasing the average time to form a wing section to zero point 0.8 hours. Note that the main focus of Proposal 1 seems to be a reduction in power. Now, Proposal 2 is substitute a younger, less experienced inspector. Now, this inspector would have the inspection time probability distribution with a mean of 7.2 minutes and a standard deviation of 5 minutes. Now, this inspector is in a job classification that calls for total compensation, including the benefits of $38 per hour. Now, the current inspector is in a lower job classification, and their compensation is $34 per hour. Now, the inspection times for each of these highly trained, experienced inspectors are typical of those of the same job classifications. Now, basically, our task is basis of comparison which evaluate the current status quo. The effect of proposal one, what would be the effect of proposal one? Make specific comparisons to the results from part A. Now, effect of proposal two, determine the effect of proposal two, then explain this to Jerry Carstairs and make again specific comparisons to results from part A. Now, finally, we would make recommendations for reducing the average level of in-process inventory at the inspection station and at the group of machines. And yeah, for that's it for the case facts.
Hi, this is Robin Eduvane. To discuss the question A, which is to provide a basis of comparison, begin by evaluating the status quo, determine the expected amount of in-process inventory at the presses and at the inspection station. Then calculate the expected total cost per hour of the inspection inventory, the presses, and the inspector. So, my answer is that the status quo has 10 presses in wing sections using random arrivals of 7 per hour and exponential service time at mu equals 1 per hour with an mm10q. Rho of 0.7, LQ equals 0.517, and L of equals to 7517 in system items. The inspection station which exponential inspection rate at mu equals 8 per hour is an mm1q. Rho of 0.875, LQ equals 6.125, and L equals 7. The total average in process inventory is 14.517, and it carries the total cost of $237.27 per hour at the cost of $16 per hour per item. The cost of running the press 10 times $14 equals to $140 per hour, and the wage of inspector $34 per hour amounts to a total approximate of $406.28 per hour.
Hello, I am Terrell Villanueva. I'll be answering the question, what would be the effect of Proposal 1? Why? Make the specific comparisons to the result from Part A. Explain this outcome to Jerry Carstairs. The effect of Proposal 1 would be that the process output rate would be reduced from 70 units, it would go to 58.3 units per hour. This would be possible by increasing the time to farm each wing section to 1.2 hours. It would result in a slightly slower production rate, but this would help ease up some pressure of the inspection station as they can really handle only 8 units per hour. This would result in the in-process inventory at the inspection stage slowly decreasing, which would lower the inventory cost. As well, the operating cost of each press would be from $14 to $13 per hour. The decrease of this would save in total $10 per hour as there are 10 presses. Overall, the effects of Proposal 1 would help the system be balanced and better as it cuts down the total in-process inventory and cost.
I am Ardilu Martin and I will be presenting letter C. Determine the effect of Proposal 2. Make specific comparisons to the results from Part A. Explain this outcome to Jerry Carstairs. In Proposal 2, the new inspector has a faster average inspection time of 7.2 minutes, or about 8.33 inspections per hour, compared to the current rate of 8 inspections per hour, although the inspector has higher variability with a standard deviation of 5 minutes. This improvement helps increase the system's inspection rate and decrease the queue size at the inspection station. Compared to the current setup, modeled as an M/M/1 system with rho equal to 0.875 and an average queue length of 6.125, the new setup has rho approximately 0.84, which results in a shorter average queue and less in-process inventory. Now, while the inspector's hourly cost rises from $34 to $38, this is partly balanced by savings in inventory holding costs, which are $16 per hour per item. So even though total operating costs are slightly higher, the system flow improves significantly, with fewer expensive wing sections stuck in queue. Overall, Proposal 2 improves responsiveness and efficiency, and the moderate cost increase is justified by the reduction in inventory.
So for the explanation recommendation to reduce and process inventory at the presses and inspection station, we recommended a few key changes. First, lower the press output from 70 units per hour to 58.3 units per hour to match the inspection station's capacity of 8 units per hour. This will ease congestion and cut operating costs to $13 per hour per machine, saving $10 per hour overall. Second, improve inspection efficiency by increasing the inspection rate to 8.33 inspections per hour, as suggested in Proposal 2, which justifies the slight wage increase for inspectors from $34 to $38 per hour. Finally, use buffer management and queuing strategies to further improve flow. These changes will help balance operations, reduce inventory, and lower the current total cost of $406.28 per hour.
In this video, I built three Excel tabs to analyze in-process inventory and cost. On the first tab, Process Analysis, I entered an arrival rate of 7 sheets per hour, a service rate of 1 sheet per hour per press, and 10 presses. Then input the press operating cost and inventory carrying cost. From those values, I calculated utilization, the average number of sheets being formed or waiting, and the total hourly cost for the presses. On the second tab, Inspection Analysis, I set the arrival rate to 7 wing sections per hour, the inspection rate to 8 per hour, and inspector, then enter the inspector's wage and the inventory cost to compute utilization, average items in inspection, and total inspector cost. Finally, on the status quo baseline tab, I summarize both stages in a three-row table, showing the press results in the first row, inspection results in the second, and the combined total inventory and total cost in the third, giving a clear picture of the current system's performance.
That has been our second case analysis. Thank you for listening.